Hi guys, my name is Chris, this is Patryk. We are from BlueSoft. We came here today from Warsaw to talk about two buzzwords. What is better than one buzzword? Two buzzwords working together. It's actually those two buzzwords, if combined, they are working and fitting together perfectly. And those buzzwords are platform engineering and generative AI. We'll be simply talking about how to use platform engineering concepts into simplifying and making generative AI adoption, RAG implementations cheaper, faster, more secure, more reliable, cost predictive, and so on. And simpler for the developers, meaning cheaper. So first of all, we will talk about how we understand the platform engineering. Besides the technical concept, it's also more actually an organizational concept. So we will define this so we have a common understanding. And then I will let Patryk to present you with how we adopted our own internal developer platform, also to be able to handle RAG's delivery, which we do for like more than a year for now. I will quickly introduce myself. My name is Krzysztof. I work in BlueSoft for 7 years, in IT more than 10. I started as a programmer, then architect, then manager, then I hated it, and moved back more into the technology consulting right now. I'm a team topologies advocate. I'm also academic lecturer in platform engineering course, and I also convinced Patryk to join me in this endeavor. So Patryk, if you can say a few words.
Hello, my name is Patryk. I'm solutions architect at BlueSoft. More than 7 years of experience, and my areas of interest is platform engineering, generative AI, and also software supply chain security. And as Krzysztof said, we are also co-leaders of Polish platform community, so we also invite you, so you can also present in our Polish community if you want. And also I try to share my knowledge with the students at Polish Japanese Academy of Information Technology.
Thank you. So as promised, first, sorry, spoiler alert. First, we will start with how we understand the platform engineering concepts and how we understand the strengths. So I selected two, I think one of the best I found definitions. First is more about why, second is more about how. So why we do platform engineering? Simply to enhance developer productivity. So the complexity of the overall software delivery, not only technical part, but also organizational part is reduced. Why? Because we want to make it more productive. We want to make it cost-effective, faster, more scalable, and so on. How we do it? We offer the right capabilities as a platform team, so the developers can use technologies, use organizational processes, and so on, without a lot of burden, without huge cognitive load, which they usually needed to overcome. I think my favorite understanding of the platform engineering concept comes from team topologies, obviously. So team topologies says that we are having 4 kind of teams in organization. I will focus on those 2 stream-aligned teams, which should be focused fully on delivering applications supporting business value streams. So what they should do, they should focus on the business mostly. Like they should deliver features on production, they should operate those features on production. They need to make sure that those features are valuable to the business. What they shouldn't do, they shouldn't fight with technology, they shouldn't fight with organizational processes, they shouldn't fight with compliance. Sometimes all of those things, which we call cognitive load, is handled by the platform team for them. How is it handled? It's packaged and offered them as a service. As a service, meaning that it's easy to use it, simply. So what platform team does is platform team makes a system to make and create and operate other systems. So kind of an easy definition. Our definition is that if we treat the software delivery as a normal business process in the organization, no different than accounting, no different than sales, marketing, and so on. And we think that developer operational guy is our business guy. He's the actor, she's the actor in the process. And we build the system for those users to be used so they can make their work faster, better, more reliable. How is it different than DevOps? Spoiler alert, it's actually not very different. The difference is that, like usual old-fashioned DevOps focused more on the process itself. So we have analysis process where we do the stuff. We have development where we code. So the DevOps engineer is preparing some kind of repository for artifacts for the code as a code, so it's reliable. They prepare databases also as a code. They deploy SonarQube for quality control. They create as pipelines and so on and so on. So that each step of the process is automated, is covered with tooling. What platform engineering adds upon this is that we have all of those old-fashioned DevOps, plus we think about how to make all of those steps working as one system and scalable and efficient for the users so they can simply be part of this process. So we are not only automating particular steps, but we think about, okay, how to make the whole process more reliable, more efficient, more faster, simply, and cheaper. So who is the good platform engineer? Good platform engineer is a DevOps engineer who realized that the developer and the developer experience and the developer productivity is the most important part of my job. So I need to make sure not that Terraform works, but I need to make sure that the developer is able to deploy the application to the production without any burdens, without any cognitive load. So as a good platform engineer, I focus more on automation. I focus not only on the automation, but also on the developer experience and developer productivity. I'm not focusing only on tools. I'm focusing also on how the tools are being used, if they are used and provided to the developers in a way that they can understand it. Example, how can this be done? Imagine that you have new team coming to the company, new stream-aligned team, new hire, they came today and they want to build a new application. So a good platform team exposes one simple interface. It can be Portal, it can be chat, it can be Jira, anything they can simply use. And this need that we'll be building application is provided to the platform team with the words understandable by stream-aligned team, meaning that they will not be providing specifics on what kind of namespace they need. They will not be providing specifics on what kind of IPs exposition should be done, but they will tell them that, okay, we'll be building new internet banking with Java. We like Postgre database. We want to expose our APIs to those customers. We want to consume some other APIs from this, and this system. Everything which simply developer after business analysis knows. What the platform does. Platform is not asking technical questions, shouldn't, like technology-oriented questions. They, through the orchestrators, are providing the complete environment for the newcomers, meaning complete environment, meaning there is a code repository and the developers have access to this code repository. In this code repository, there is a demo application. This demo application has all the CI/CD pipelines which deploy this application on the dev environment, SIT environment, prod environment, everything application to be provided to the end customers. It has database already connected. The application is visible in observability tooling. There are indexes in this observability tooling. Application has network connectivity to all the systems which are going to be integrated and so on. And this is done in, we say 15 minutes or less. Why 15 minutes? Because this is our record in one of the banks we worked for, that we actually achieved that in 15 minutes. Why? Because, and what kind of cognitive load we address? The waiting cognitive load, the configuration cognitive load, all the things which are necessary to start. So we simply make the production delivery from the first day happen. So this is a result of one of the service which can be provided from the platform team to the stream-aligned teams. That can be other services, new environment, new integration, so all the network configurations needs to be opened and so on. This is standardized. How it looks like from behind the curtain. Behind the curtain, we have all of those classic DevOps stuff automated and concluded. What we put upon as a platform is this service layer, which is, I believe, the most important in platform engineering world, where we have orchestrators which provides all the changes in all of those Pokemons on all of those tools, which is necessary to make this service happen. So if we think about the previous example, we have this application provisioning, which we called, and this application provisioning is creating a new repository, is putting CI/CD into this repository, is putting the demo Java application, is creating new namespaces and Kubernetes, new indexes, and so on and so on. Why? Because we want to achieve this fast flow. Again, why we do it? What's the biggest benefit? Many people say that the biggest benefit is developer experience improved. I disagree. I believe that this is the side effect. The biggest benefit is that we improve the time to market for business applications. Simply, developers are not waiting or fighting with the tooling. Thus, we have this cost efficiency because they are not spending time over and over. Like if we have 30 teams, 50 teams, 60 teams, if we do not provide it as a service, each team needs to configure something. And this configure something takes time. Time is money. So also, we do some kind of cleanups because in order to provide automation in those full environment delivery, for example, or new environment delivery, we are not able to automate everything which we find in the organization. We need to decide which tooling we need to keep up and which tooling we need to get rid of to do the automation in efficient way. Also, we improve the communication because services define some standard barriers between the teams. So we have the responsibility boundaries. We know what the platform is responsible for. We know what the stream-aligned team is responsible for. And all of this, those boundaries should be taken from the cognitive load discovery. So each successful platform, we always start with cognitive load discovery. So what is this burden? For some teams, configuring Kubernetes can be a burden, but for other teams in more mature organization, this is something which is very simple. But for example, regulations is the burden. So as a platform, we need to discover this. It's very actually this discovery we thought it's over like a few years ago when we started to build a platform for our company, but then AI came, and AI produced new cognitive load, and our platform team needed to address those as well. And Patryk was the right guy in the right place doing this.
Okay, so I will step in. So regarding the second buzzword, yeah, it's not surprise that the generative AI has emerged as a major technological trend, and of course it is expected to remain significant in coming years. As you see, according to Gartner top 10 strategic technology trends, 7 out of 10 trends are either directly or indirectly related with the AI. But as you see, among these trends, there is also platform engineering and industry cloud platforms, which represent some platform-centric approach. And later in this presentation, we will try to answer whether platform engineering practices can address the challenges which are posed by these new trends. And of course, we will try to share our experiences and experiences of our company, but it would be good to have some context where we position ourselves in this whole AI world. Yeah? So using these 3 simple generative AI strategy archetypes, we place ourselves somewhere in the middle. Yeah, so we are not the makers. Yeah, we do not compete with OpenAI or Google to create better foundation large language models. And these companies operates, on huge amount of data and massive compute power. But also on the other side, we assess that some low-code, off-the-shelf solutions are not sufficient for our use cases and for the use cases of our clients. And that's why our development team's focus is on creating production-ready LLM-based applications, which are either created in the RAG architecture or in the multi-agent architecture. And regarding this architecture, this is the first example of the new cognitive load. So we have new type of architecture, application architecture, which has emerged together with the generative AI. It was firstly proposed in 2021 in the paper, and of course at the end I will put some sources, so you will have all of the links. And this new type of application architecture, it utilized the large language model to answer some user questions, but a part of the model which has some general knowledge about the world and physics, etc., we also use the external knowledge which is most often some proprietary private data which some particular company or particular business units own. Yeah, and in this type of architecture, this additional knowledge is queried, and some part of information is fetched from this type of data to really answer the question of the user, keeping into account some general facts and also some data which was not available during the training of this large language model. And most usually some common use cases of this type of applications are different kind of AI assistants. We saw some examples of, for example, AI assistants which were developed for some retail chain company which has many shops, and for example this company decided to provide for their employees some system which will help these employees to navigate through different processes, different instructions which are specific to this organization, which were specific to this data. And another example was from a brewery company. So some functions like text-to-speech and speech-to-text were added to this type of assistant to give the sales representative who is driving the car and who spends a lot of time in the car easy access to the data, so he can check some, sales targets or any other stuff while he's driving, and he will not waste time. And things become more complicated when we are dealing with the multi-agent architecture. Yeah. So on this slide, you can see example architecture of a system which is being developed on our platform. This system is named Codezilla, whatever. But the goal of this system is to support IT operations team in maintenance of legacy system. Yeah. And this architecture, this another type of architecture, again introduce new layer of complexity due to the characteristic of these multi-agent systems, which are, for example, decentralized collaboration between the agents. There are different agent topologies, different conversation patterns. These agent-like systems also use some internal memory, and also, of course, some of the agents could be implemented in the way that they execute some actions on external systems. And of course, the next cognitive load, so with the introduction of this new type of applications, of course, there are new risks and threats which should be addressed. And these risks or threats should be addressed either at the platform level or by the development teams. Of course, we prefer to address some of these risks centrally. Yeah. And what you see here is the threat model which we built for these applications. It is extension of the OWASP top 10 for LLM applications. And of course, we do not have enough time to deep dive into the different aspects of AI security, but I encourage you to check our talk from Secure AI Summit, from June. We gave some presentation in Seattle where we presented some outcomes of our research and also implementation, how to secure and how to secure the applications and how you can handle such problems. Yeah. But what is important to note here, again, we have new knowledge, new aspects which needs to be addressed by the organization. And can we say that building solutions based on large language models is easy? Well, I think it is not, especially if we aim to achieve high level of quality and reliability of this kind of systems. And this new cognitive load is mostly associated with the new implementation techniques. Yeah? So this simple rack pipeline, which I showed you earlier, it can be optimized and at different stages. Yeah? So there are multiple ways how you can build the knowledge base, how you can embed the information into this knowledge base, in which way you retrieve the information, these chunks of information. Do you somehow re-rank them? Do you compress this data? How this data is sent to the large language model together with the prompt and with the original query. So there are multiple methods which you could add at the application level. And of course, there is also quality aspects of these new types of applications. So there are different metrics which measures different stages of, for example, rack applications. And for each of these stages, there are also metrics which again use a large language model under the hood. This is LLM as a judge model, but also some typical metrics. So to sum up this lengthy discussion, one of the key observations I have noticed across various development teams in our organization or on the client side is that there is some change in the way how developers work. Yeah? So instead of some crafting-like style of work, yeah? So you use well-known good design patterns to understand and solve some business problem. Now they change this workflow in the way that they spend more time, on iterating and trying to apply these different optimization methods to really satisfy the quality needs and to solve the problem based on the data which they have and some requirements from the business. Yeah, and here is actually this new cognitive load. So this style of work change. Yeah, and as a platform, we need to support the delivery teams to speed up the time of these iterations and in overall to speed up time to market. Yeah, and here is our answer. So to address this cognitive load, we built the Starboost for AI. So this is our cloud-native AI development platform. And as you see, this platform is composed of 4 layers. Of course, at the bottom we have infrastructure layer with our beloved Kubernetes. Then we have the foundation layer with some pretty common set of technologies from the cloud-native portfolio. At the top, we have the platform portal, so usually using Backstage. So this is the way how we present and give access to the services for our engineers. But the most interesting aspect in our case is this services layer. So, yeah, and this services layer can be implemented really in different ways. Yeah, it could be Kubernetes operator, it could be some pipeline in the backend, it could be some set of microservices. We also have it. Yeah, but what is most important is that to design and implement these services to really address the needs of users, yes, and to present these services in the form of the API, yeah. And some example of the services which we discovered and built for our teams is, for example, rack provisioning service, yeah. So to avoid reinventing the wheel and to reuse existing RAG templates and optimization techniques which were already developed, we exposed such service to the developers to quickly provision the simple RAG application and to start working on new use case with some predefined set of code and predefined set of features. Yeah? Then, for example, we have the experiment and evaluation service. Yeah? So we did the research once, we implement some set of metrics which I mentioned before, and we simply expose calculation of these metrics to the user in a as a service manner. Yeah? So they can enter the portal, select the service, load some test data which could be created by them or provided by the client, and simply click to run the metrics, calculate them, and get the report. Yeah? And thanks to it, these teams can make some informed decisions about the progress, about the quality of their applications. Yeah? And we invested time to do this once, and then of course we constantly improving it. But you know what I mean regarding some reusability of this type of services. Yeah. Also, we, for example, implemented the LLM provisioning service. Yeah. So we expose the large language models through our platform, and either if these models are proprietary ones, from OpenAI or from Google, or some open source models, we are provisioning them via the platform, and the developer can click the model, get some template code in Python with the URL. Of course, we use the OpenAI compatible API and some key to access the model. But under the hood, developers do not know that we also made some significant research in this AI security area, and all of the traffic which goes into the model and goes out from the model, it is sent via the AI gateway. Yeah? And having such AI gateway, when all of this traffic flows, we can apply some security measures centrally. Yeah? So for example, implement some content safety methods or security prompt enhancement. Yeah? And from the user perspective, of course, they will, from the application, they will send the request with the prompt, etc., but they will not even see that, for example, before these requests reach the model, we, for example, can use another model like Meta Llama Guard from Meta, Llama Guard 2 from Meta, and for example check the content safety, and if this content has some violent speech or something like this, we will block this traffic. Yeah, and of course we invested it from very beginning. It's especially important in the AI and when you use the large language models to have some centralized monitoring, observability, and cost management. Yeah, so it's really important to track the costs, especially for such R&D projects, because at the end you need to assess, does it really work, and do we save some money or do we earn some money or not? Yeah, because the time to develop it, the cost of the model, etc., is simply too big and not optimal. So it's really also really important to have it from the beginning, and to highlight the role of the platform and the goal of the platform. I want to show you this diagram. Yeah, so as you can see, this AI engineer is at the center of the process. Yeah, so our goal as a platform team is to support these engineers and offer them some capabilities in the self-service manner to accelerate this build, measure, and learn cycle. Yeah, so developers can focus, on optimizing these solutions, trying to achieve the desired quality, while the platform is simply handling some part of this cognitive load. Yeah? And from the technology perspective, as you see, a part of this pretty standard set of technologies, we, for example, using VLLM for large language model serving, or some of the teams use Milviews database as some vector database, or for example, we are using this Ragas framework to calculate these metrics, but also we extended this framework after some iteration and testing. Yeah, but also another thing which I want to highlight here is to treat this AI platform as not some separate entity. It's not the revolution. It's rather some evolution of standard internal developer platforms, but simply with new cognitive load addressed. Yeah, so nothing really fancy. So to sum up, from our experience, we see the benefits of traditional platform engineering practices in this new field, in new area. And of course, you know, the benefits which Krzysztof said, like time to market and some cost reduction, they are also applied in this, let's say, new style of development. As I mentioned on the previous slide, the AI development platform is, you know, not something spectacular, rather some addition to the classic platforms, and you can, like we did, you can combine it with the technologies which are already available. But what is, I think, most interesting from all of this stuff is scaling and onboarding. Yeah, so if you invest into these capabilities, and if you try to abstract this complexity at the platform level, then you are ready for the future. Yeah, so you can scale your AI program, and you can onboard new members or new teams much easier. Yeah, because they will not need to start from the scratch. Yeah, and also, as you see that, like in every company, there are some pioneering teams, there are some other teams. Yeah, and this having the platform is also some place where you can somehow compress the knowledge and reuse it. Yeah, also for the other teams, and at the end improve the return from investment. Yeah, and yeah, the last observation is of course the cloud native approach, like we did, and usage of open source technologies, especially in this field, which is rapidly developing. There are new models, new frameworks, new techniques. It's really important to provide you and your organization the flexibility to change the direction in the future. So as I promised, there are some sources which you can take a look after the presentation. Yeah, some of them are papers. I also reference these security topics, and also there are communities. So MLOps community, I think it's one of the interesting places to take a look. Also the Cloud Native AI working group, and from the platform engineering perspective, also there is working group in Cloud Native. So thanks a lot for your attention, and yeah, we are happy to answer any questions either now or later.
Yep.
Thanks.
Thank you.